have a diagram with so much going on. Now this one at first one doesn't look too hectic, but guys, if you look at the two triangles that they're asking you to prove, they're asking you to prove BEX, which is the bottom triangle, and then BXB, which is that whole triangle. So some of the angles are kind of overlapping. What I can suggest is that you actually list the angles in the one triangle. Are we listening? And then next to it, you list the angles in the other triangle. That will just give you some clarity as to which angle you're actually trying to prove. So if we're looking at BEF, we're looking for EBF as one angle in that triangle. All right, I'm looking at the bottom one. Then BEF is another angle. And then the third angle in this triangle is BF. Okay, so now I at least know I'm looking at those three angles as opposed to just looking at the diagram all the time. All right. Then in the other triangle BAC, which is the whole one, we have EBF again. And guys, the fact that I didn't do this made me notice or made me not notice that we actually have a common angle from the start. Okay, so I made it a bit more complicated for myself. You'll see there my third one is saying that EBF is common. But if I had done this from the start, I would have seen that straight away. Okay, so we'll talk about that now, okay? So looking at BXB, so now the whole angle is BXB there. And then also BDF is the third one. Yeah. We've now just been told, and I'm saying we're not allowed to get everyone out of the class in the first 15. Was kids are using up in the bathroom, they're out of the class to after break. No, there's a lot of sacred stuff going on in the school. Yeah. They can, yes, but it's just to stop people from being out. With my grade 8, literally at the beginning of every single lesson, there's 4 kids that want to go. And it's always the same thing. And I can't say no, because they're like, no, but they always like, can I go to the bathroom? Can I go fetch my book? Can I go here? Can I go down? It's always the same thing. Yeah, guys, try to have your books with you, basically, because no one's going to let you go, at least not today. Everyone's going to, project standards are just like the first thing. Okay, guys. Are we fine with the list that I've made then? Now, just again, why I'm saying that is so that you can actually see, look how easy this is now. Now I can see immediately that is a common angle. Where, if you were like me and you were looking at the diagram, I don't know why I didn't see it at first, but I didn't notice that that was a common angle. Okay, but if you're listing them, it just makes it easier to notice. So what I did, yeah. You don't even have to write the reason. You just say this angle. Okay, that's the only case for me. Guys, these focus for you. All right, so now you can see I use dots and yeah, I use some symbols here. So for these, so that's putting your first line, which is great. But then for one of these two angles, you would have had to do like a multi-section. So you couldn't go straight from one angle to the other one. So if we're looking at this one with the dot in it, right? They told us that AC is a tangent. So I thought immediately, okay, let's check the tan chord theorem. So this angle here, the one with the dot in it, oh, this is moving. That angle there, do you remember how tan chord theorem works? The angle between a tangent and a chord, so BS in this case, that dot, is equal to the angle subtended by the same chord in the other segment, right? So that angle there, ABF, will be equal to BDF. And BDF is an angle in the segment. But now, is ABF an angle in one of the two triangles that I'm trying to prove? No. But do we notice the Z shape here? Right? So using using alternate angles here, you could prove that EFB was also you could prove that EFB was equal to this angle. Right, sorry guys, I was working. I don't want to get in trouble. Okay, so basically you could prove that both of those angles are equal to the same outer angle. So they must be equal to each other. Okay, so that's the first one that I actually wrote down. I said EFB is equal to FBA because of alternate angles, so that's the red shape that we have. So FBA was that outer angle, or ABF, all right? And then BDF, which is the tan chord theorem one, is also equal to FBA. So guys, since these angles are both equal to the same thing, they have to be equal to each other. All right, so that was a multi-step one that we have to do this. So guys, if your first reason was EBF is common, and then you had either this one or that one, so the other one, it was the exact same process, it was just in the opposite direction, right? If EBF is common was one of your first two, then you would have just had to do one of these, and then you could have just said for your third line, FEB is equal to BFB. Okay? FEB is equal to BFB, and then your reason would have been angle sum and triangle. Okay, does everyone hear that? So if you didn't do both of these difficult ones first, if you put EBX as common as your first or second reason, then the third angle, you didn't even have to look for a way to prove that the third angles are equal, guys. You can just state that they're equal and your reason is angle sum and triangle. Yes. You have to show which one is equal. Okay. And it's very important at marking, we always look for this pair and the reason there. So that will be like one mark for that pair and the reason, and then a third mark for second. Okay. So yeah, unfortunately you can't just write both of them. Okay guys, so this was a bit more complicated than the ones we did yesterday, right? And we are heading in that direction all the time. It's all gonna be like this if you get any of the yes. I don't know how to do this, but what would we have a common yes, yeah. The similarity is just that. Oh, yeah, all the sides. That reminds me, we must still do an example with sides. Now guys, what you can also do here is once you actually figure out, okay, EFB and BDF are equal, EFB and BDS, these two are also equal. What is going on? I think it's my jersey. Those two are also equal. Then the third pair, you can do like a dotted line there to show that it can just be your angle sum and triangle pair. Okay, when we're writing it out. I'll do another example with you now, and then I'll go into the whole process. Okay, then to B, they've asked to prove that BX squared is equal to BB times BE. Guys, like I said yesterday, 9.9 times out of 10. The second question will have to lead on from your similarity statement here. So this was your similarity statement. Let's just go over the actual listing of your angles here. So I did BEF. So if we look at B in the first triangle, B was equal to B in the second triangle, right? Because that was a common angle. The second letter was E. Then you need to look at E. Yes. Then you look at E. E is the second angle there. E was equal to F. You see? Right? You have to actually look at like which letter is equal to which letter. Okay, and then the last angle was F. F was equal to angle G. So F and G must be on the same. That's very important, guys. If your similarity statement is not correct, your fractions are completely wrong. And you won't be able to prove what they're asking. Okay, so now I went from my similarity statement. You can see it over there. You can do your frog faces. BE over BF is going to be equal to EF over SG. Is equal to BF over BD. Then I just ticked off the sides that they asked me about. Now guys, BX squared is the same as BF times BF. Right? Do you agree with that? So when they say BX squared, they're actually saying BF and BF. Now BF was a common side in both of them. Okay. So I ticked off that BF and that BF. Then I ticked off BD and BE. So we're looking at those two fractions. Now guys, all you have to do from here is if you multiply that VS out, you get the VS squared, and then if you multiply that VB, you get that one. Okay. We are going to do another example. I think just from the same exercise. So that was number 2. Let's do number 6. We'll do it together? Yeah. Oh. Okay, guys, I'm just quickly drawing the diagrams. Okay, give me a second. Just No. Oh wow. Okay, guys, let's take a look. That is the diagram in 6. So what they're saying, can we all tell that we have 2 circles? So I'm going to draw it. It's in your textbook. I just drew it so that I can write on it. So what they're saying here is that PQ is a common tangent at A. So by that means that PQ is a tangent to the small circle and to the big circle. All right. So guys, all that they're saying in this question is prove AC over AE equal to BC over DE. We're not even mentioning similarity. But I want you to think like a question like this, and it will always be like in the last question of an actual final exam, right? They always put the similarity and the proportion questions right in the last one. What you're going to have to do is you are going to have to prove that 2 triangles in this picture are similar, and then use your front pages to get to this fraction. Okay. Now, the difficult thing here is that they're not telling us which triangle to prove. I think it's not that difficult to figure out that we must work in triangle A, B, C, and triangle A, B, E. Those are actually the only 2 triangles that we have in this case, right? But if you think back to number 2, like we did for homework, I'm just going to go back up to that picture quickly. In number 2, how many triangles were there? 1, 2, and actually 3. All right, so I'm going to show you now a way of figuring out which triangle to work with in case there are lots of them. Okay, like I said, in this example, I think it's easy. The only 2 triangles that we do have here are ABC and AB. Right? Is there another triangle in this picture anyway? Anyway, sorry. This shape here is not a triangle, right? So we know immediately we have to work with ABC and AB. But if there are lots of triangles, how do we figure out? Now, guys, what you're going to do, thank you, is you are going to look at the fractions that they ask you to prove. Okay. So we're going to look at this first fraction. And we're going to do various things. We're going to look within each fraction And then we're going to look across. All right, if we're looking within this fraction, which three letters do we have? A, B, and E. So you're going to ask yourself, is A, C, E a triangle? Right, well, obviously not going to write that down in a textbook now, but this is what you need to think. Right, you're going to look within the fraction. If they haven't told you which triangles to work in, you look at the letters within the fraction, A, C, and E. Right, sometimes you're going to get four letters. Can it then be a triangle if there's four letters? No. All right, but here we have three letters, so we look, is A, C, E a triangle? No, it's actually a straight line. Okay, so you're going to say no, so we can't work in triangle A, C, E. If we're looking at the second fraction, that actually happens in the second fraction that we have four different letters. You guys see that? B, C, D, E. Can that possibly be a triangle if it has four letters, four vertices? No, okay? So is B, C, D, E a triangle? No. Okay, so I'm just going to write on the side here. This is in each fraction that we were looking at. Basically, we're checking which letters are within each fraction, and we're checking if that gives us a triangle. If that doesn't work, guys, you're going to look across. You're going to look at those, the letters at the top, and the letters at the bottom. Which letters do I have going across? A, B, and C. Is ABC a triangle? ABC? Yes. Okay, so I'm actually going to put a little triangle there in front. That is a triangle, so we're going to work with that one. And which letters do I have here at the bottom? If I look across, A and D and E. Is ADE a triangle? Yes. Okay, so that is giving me triangle ADE. So that means that we are going to work in triangle ABC and triangle ADE. We're going to prove that those two triangles are similar. And then when we do our frog faces, we will be able to get these two fractions. Right, because these will be sides in these two triangles. All right, I've checked for the letters, so all of these will be sides in the triangle. You can check that as well. If ABC is AC a side of ABC? Yes. Is BC a side of ABC? Yes. All right. In triangle ADE, the one at the bottom, is AE a side? Yes. A triangle ADE, right? And what about DE? It's that side over there. Okay, so if I'm able to prove those two triangles similar, I will get this fraction or these two fractions equation from the cross faces. Okay, so then we're going to say here, back to black, we're going to say in triangle, in triangle ABC and triangle ADE. Now guys, what I said earlier, again, in this step, it's not that difficult. You're happy? But again, to get ourselves ready for the very tricky ones, there's a lot going on there. So list all the angles in triangle ABC and all the angles in triangle ABE next to them, and then we can match them up. Then the actual writing out of the proof will be easier. So in triangle ABC, which angles do we have? ABC is A2, B1, and C1. Right? So we have A2, we have B1, and this is just kind of a part of your work, and guys, you can do it on the side somewhere. So if you have space, you can do it in pencil. You're not going to get marks for this, but this will make the actual writing out of your similarity proof. Okay? And then if we're looking at ADE, which angles do we have? Again, A2. Then we have angle ADE. And we have angle AED. Now, what do we see straight away, guys? I'm getting it. A2 is common, right? You can see that very easily if we write our two angles next to each other. And that's sometimes you can be able to do this proof without writing this out. Okay, this is almost like a backup for if you really can't actually make it without of what is going on. Okay, so you can always list the three angles, list the three angles. Sometimes when I'm doing a really hard one, I still do that. I still list them. Okay, just two kind of arguments. Okay, so we have one pair of angles. Now we need to prove only one more pair of angles equal, guys. Because remember the third thing, we can always say angles are a triangle. Now the fact, again, that they told us that PQ is a tangent should be a hint that we're going to have to use tangent here. Okay, it's actually similar. No, not quite. It's a bit easier actually than the one that you had to do for homework. Let's look at A1. Yeah, A1, if this is a tangent, remember the tangent is a circle and a big circle, right? So if we're looking at a small circle, do we agree that A1 is going to be equal to C1? Because the tangent is here, right? So A1 is going to be equal to C1. But since PQ is a tangent of the bigger circle as well, which pair of angles will that be? A1 is going to be equal to angle E, also because of tan chord. Remember, the angle between the tangent and the chord, which is AD in this case, is equal to the angle subtended by the chord in the opposite section. So that would be the angle at E. So guys, there we have it. C1 and C are both equal to A1. So they have to be equal to. All right, so C1 and AED are going to be equal. So that means that for my third pair, I can write angle sum and triangle for B1 and AD. So guys, if you wanted to, you could have, it would have taken longer to write out, but you could have done exactly the same thing in terms of tan chord theorem with B1 and B as well, right? You could have said that A3 is equal to B1, tan chord, and A3 is equal to the angle at D, also because of tan. Now let's save some time. We're not going to write down unnecessary stuff, okay? It's going to be quicker just to write down angle sum and triangle. Okay, so for the first one, A2 is common. So that one is done. Now we need to write out both of the steps leading to C1 being equal to AED. So for the second one, we're going to say A1 is equal to C1. Okay, now because they have the same reason, we can actually write it all in one line, guys. So A1 is equal to C1, and A1 is also equal to, what's this angle? AED. All right, unfortunately, we have to write the whole angle there. AED. And then the reason for both of those, just because it is the same reason, but you're still writing two separate statements, is tan fluid theory. Therefore, since these are both equal to A1, they are equal to each other. So C1 is equal to AED. And you don't need a reason for that statement, guys. That's just like being that they both equal to A1. Yeah. I have to forget I don't know. In final guys, it's like a million, but I'm just for one as well. Okay, number 3, the third pair that we just did the dotted line for. So it was B1 equal to ADE. And the reason for that will just be angle sum. Therefore, triangle. So guys, when you are writing the similarity statement, you can always decide the order for the first triangle. I normally just go with alphabetical order. That's very matter, but I'm gonna say ABC for this one. ABC is similar to, and now we need to match up the angles of the second triangle with the angles of the first. So since I wrote A first, we see here A2 was common. Alright, so the A angle in the first triangle was equal to the A angle in the second triangle. So I need to write A first here as well. Next up, I wrote B. Now here is B from the first triangle. We see that that was equal to the angle at D in the second triangle. So I have to write D next. And then C in the first triangle, C1, was equal to E in the second triangle. So I have to put E first. So in this case, it worked out that they were both in alphabetical order, but we know that that one Right, and then you can say angle, 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 or angular, if you like it. And now we're going to set up our frog faces, because remember they asked us to prove that actually. Right, this is not the end of the picture. But now you can just look at the sides that they asked here. You don't actually have to do all three fractions. We're looking for AC over AE. Can I get that straight away from doing my frog faces? AC over AE, right? That's the mouth of the frog, not all the mouth. That is the what this thing is doing here today. That's that pair, right? AC over AE. So you can write that straight away, guys. AC over AE is equal to, and what was the second part of that fraction? BC over DE. BC over DE. Another triangle. Sorry, I almost forgot my reason. There we go. Yes. I'll just hold that. All right, guys. Are there any questions on that? No question. We're fine. All right, I'm just going to give you some more of these to practice. Okay, for the ones that I'm going to give you, remember if there are more than two triangles, please, you're going to have to figure out, if they haven't told you which triangles to prove, you're going to have to figure out by looking at the fraction, or they can also give them in ratio form, right? They could have written AC to AE is equal to BC to DE. You would do the same process. Okay, the same thing, same method. You need to figure out which two triangles you're going to work in. First, you check within each fraction. If that doesn't work, you then check across. Okay, to figure out which triangles. Then, once you figure out which triangles, if there are, again, lots of triangles, or if there's a lot going on, or if you just want to make it a bit easier for yourself, you can list the three angles in each triangle in order to like clean them up like that. But guys, unfortunately, your knowledge of circles is quite important for this section. Okay, so if you're very rusty on circles, you're gonna have to maybe just make like a little summary. I think I did post already 11 notes on your Google Classroom, and there was that big geometry summary document for all the circle geometry summarized on there. So you're probably gonna have to take a look at that. Okay. All right, so your classwork turning into homework if you don't finish is from the same exercise. All right, so you've done 2 and 6 now, so I'm going to ask you to do 3 and 9, guys. Sorry, yeah.